decision support is not a new thing. It has been around for ages, much before Arthur and Merlin, like in this picture. But now we need still improved methods to give that decision support, because the current problems are more difficult than before with climate change and all kinds of global and very complex things. We need dedicated tools and methods to give support to such decisions. It's all about information flow between people, so that the information flows into the right place, so that the person who needs it to make decisions can reach it and understand. And as an example, I picked one piece of information which is about EFSA. If you want to learn about EFSA, a reasonable thing to do is to go to Wikipedia and check the page about EFSA, and you will get a concise description of what EFSA is, what it does, and so on. And you know that you can do that, and it's usually a good idea to go to Wikipedia and check the information you're interested in. However, Wikipedia is not good for all things. For example, these are questions that you cannot find answers in Wikipedia. So these are things that you need when you're trying to do an assessment, health assessment about food-related things, like exposure response functions, like exposures or consumption distributions of some food items, and about methods how to do health impact assessment, for example. So Wikipedia is not a good place for this kind of information, because it's based on the idea that it's about kind of established information. So Wikipedia mostly uses kind of handbook references and things like from credible sources. Scientific articles are okay, but if it's in a handbook, it's better. And original data is not allowed in Wikipedia. If someone uploads original data to Wikipedia, it will be removed immediately. And yet, many questions can only be answered by publishing and using original data. So there's a need for something that is a bit like Wikipedia, but still better in some other respects. Those three questions that I presented there, they are actually questions that we needed in one assessment we did last year. It was published early this year in the Finnish Food Safety Authority publication series. It was about benefits and risks of Baltic herring. And that is an important topic in Finland, because Baltic herring, as fish in general, it's a healthy and good food. But on the other hand, it contains high concentrations of environmental pollutants like dioxins and PCBs. So every now and then we update our understanding of benefits and risks of herring in Finland, and that was one thing we did last year. What we did in this assessment was that we tried to apply the concept of knowledge crystals in our work. So what are these knowledge crystals? They are things that you can use when you are doing assessments, and here is a characterization of what I mean by knowledge crystals. So it's an information object which answers a specific research question. It's located in a permanent place on the internet, just like a Wikipedia page. You can always find the EFSA page in Wikipedia if you're interested in reading about EFSA. In a similar way, this research question should always be in the same place on the internet, so that you can go there and check what's the current answer to that question. So the purpose of this knowledge crystal is to find out the best current answer to that question presented on the page. And it should be, the answer should be there in two different ways. one that if someone goes there and reads it, they can understand what the answer actually is. So it must be in a human readable format. But also for people who want to make assessments that are based on knowledge described in that knowledge crystal, it should be also in a machine readable format. So you just go and pick that piece of information you need and plug it into your model and run your model, and you get good results. So in addition to this question and answer, it also has rationale, so it contains any information that is needed to convince a critical reader. So it might be original data, it might be articles, it might be reviews, it might be a meta-analysis, or depending on how good your database on that question is, it might be just anecdotal guesses about how things might be. So anything that is useful when you try to convince a critical reader. A knowledge crystal is continuously updated so that when new data appears, those who maintain the knowledge crystal, they check whether you need to update the answer based on the new data. One critical thing with knowledge crystals is that participation is open. So anyone who thinks that they have important information related to this question, they can come to this website and they can give comments, they can provide data, and they can participate in that work. But this implies specific rules. So I have seen enough websites where people just come and start shouting about all kinds of things that don't relate to the original topic, and that's not what is searched for here. So there must be specific rules to maintain the quality of that page. And actually one reason why I like this idea of knowledge crystals is that if you think of the approach of media with information, so the basic rule in media is that you always want to find the second opinion. So even if a majority of researchers think that climate change is a problem and it's caused by human activity, the role of media is to go and find someone who has a second opinion and bring that to the attention of the public. And what does the researcher do when he is given 15 seconds to answer to the opponent? Well, this is a complex issue, and there are lots of things, and you cannot simplify it in that way, and that was your 15 seconds. So it's quite impossible for a researcher to reply to such a kind of attack. But with knowledge crystals, what you could say in that 15 seconds is, yes, we have that opinion or approach in our knowledge crystals, and it's included in our synthesis. And you can say that in 15 seconds, but of course it means that you have to go out and find those opposing opinions and kind of ideas that are against the kind of mainframe research or scientific understanding. And you have to describe those and think about them, and if they are poor, you can invalidate based on scientific reasoning. And then they are included in your synthesis, in your knowledge crystal. So this simplifies the work with media, because you can say, well, we have thought of that, it's included in the synthesis. And people can go and check that that is true. Now that we're looking at say, a risk assessment related to some food item, it could look something like this. Actually, there are two different assessments that are partly overlapping, but the idea is that you build your assessment based on knowledge crystals that are about the exposure response functions, about the population characteristics, about maybe decisions that could be done, about the impacts of the decisions to the consumption patterns in the population, and so on and so on. And each of these pieces you need for an assessment are based on previous work containing reports, articles, open data, some public data from, well, what I have there, data.gov or some other data sources. So the idea is that you increase the level of synthesis so that when you have crystallized that piece of information, it contains the substance of scientific knowledge you have about that specific research question, and then it's easy to use in assessments. As an example, we were doing a bit more than a year ago an assessment about vaccination in Finland, and we wanted to have comments from a public group, or it was kind of activist group who is always showing critical opinions about vaccination in general. So we wanted to talk to them, and we raised these specific things that we needed for this assessment, and we talked with them to identify possible problems in our knowledge base. And actually we found out, we had a very good discussion. They were kind of promoting the idea of open work and inclusion of different groups, and they actually did give us a valuable contribution to our assessment. It was only a minor part, so it did not change our conclusions of that assessment, but in any case it was quite useful to have that discussion with them. So how does this relate to collaborative models in practice? So developing knowledge crystals, it's kind of a knowledge work that you go on and read those articles, you collect the data, and you do all kinds of things. But finally, your aim is to have a machine-readable synthesis of all that information, and then you apply some modeling software to run your assessment model. So what we are doing in practice in THL is that we are using R software, which is open source statistical software, and we plug that with a database, and we work on a MediaWiki environment. So our website looks pretty much like Wikipedia, and all the models and the details, the code and the data and the descriptions of those data and the assessments, they are found on those pages. So when I'm giving talks like this about this open collaborative assessment or open assessments, always people ask, how can that possibly work? It will end up in chaos. All those trolls will show up and they will destroy any intellectual work you're trying to do. That is not what we experience. Actually, if you are asking very specific questions about detailed things, about exposure response functions or consumption patterns or something, people who have kind of bad ideas of participating, they have very little to say to consumption distribution patterns. They would love to talk about all kinds of things, about how the president is a stupid person and the government is doing wrong things, but we're not talking about those things. We are only talking about this consumption pattern. So it's not easy to to go trolling. And there's also one thing that I was actually borrowing from Lawrence Romberg from yesterday's presentation, which is a table like this, where you have data as rows and then possible explanations as columns. And if you look at this carefully and you think, how would you contribute into this table? So are you able to develop a new hypothesis that would fit into all of the data that exists there about this topic? Or whether you are able to provide a new row of data that is useful for this overall picture. You can see that it's not easy to join unless you know a lot about that topic. So so far we haven't seen much malevolent people who would want to mess up with this kind of assessments. I took this slide because of the discussion of pure and impure science in this meeting. In assessments, you need both facts or scientific statements and value judgments or values. And these were called as kind of pollable and non-pollable items. In my thinking, if you think of knowledge crystals, it's just knowledge about the world, and it's knowledge about people's values. And you can actually apply the same rules in both kinds of information. I don't have time to go into the rules, but it kind of helps you think when you have the same rules when you're talking about information, and you don't need to try to separate between pollable and non-pollable things. I have one slide though to show. It's about structured discussion. This is one of the methods that we use to get kind of unstructured contributions organized. So you have methods to synthesize discussions and come up with clear resolutions that can then be used in developing the knowledge crystals and used in assessments. And finally, recommendations. I have 3 points. I think this kind of knowledge crystal idea should be promoted in assessments. It could be promoted by EFSA. I would really love to see that happening. We're trying to promote that in THL in Finland. The second point, risk assessments or health assessments can be done online. We have done that for years now. And it should be done online so that you can get the most participation, the most information available out there. And to succeed in that, you need open source models and open data. And the third point is that knowledge crystals are a new way of collecting scientific information, and it's not well supported by the current systems of gaining scientific merit. So people don't get professorships if they do knowledge crystals, but that should be changed. So thanks for your attention. Thanks.
Yes, thank you very much. I think we have time for one question. Is there any question to our speaker? Yes, okay, yeah, please.
Thank you very much. I think it is a group of people being the owner of such a knowledge crystal, if I understood this. And you said you will always put the latest information and you will find the best current answer to the question. Who decides what is the best current answer?
I should tell you about the rules, how to work with these crystals, so I don't really have much time. But it's basically it's a kind of the collaborative decision based on the people who are participating. So that's the short answer. And of course, that means that if only few people participate, it will probably not be the best possible answer, and we need more people to participate so that it will become better.
Yes, thank you very much. I think for time restrictions, we have no other possibilities to have a question. Please keep your questions for the final panel discussion.